So let's get to that actual area. If I let n equal or n approach infinity, notice what I'm going to do is I'm still going to be looking at this same two functions, which was little s of n and big S of n, which was my lower limit and my upper limit. And when I looked at them before, they were getting closer and closer together. But what I'm going to do now is I'm going to take the limit as n approaches infinity. So as n gets really, really big, I'm dividing 4 by a really large number. This is approaching 0. This guy also approaching 0, so my limit is going to get closer and closer to 8/3. And if I look at the same for the upper limit, again, these are going to both end up being 0, so my limit approaches 8/3. And so that means from the left-hand side, remember we said S of n is less than or equal to the area is less than or equal to S of n. And so if this guy approaches 8/3 and this guy approaches 8/3, guess what my area is going to be by the squeeze theorem? It's going to be 8/3. So that's essentially what the limit definition says, is find the limit of the lower and the upper sum. And if you find that, that's going to be the area of your figure. So we still have to do all that work to find the lower sum and the upper sum, but those two limits should equal each other, and those limits that equal each other should also equal the area. So essentially what this is saying is if you have an interval from A to B, we can find the area by taking the limit as the number of intervals approaches infinity. So that's what we did before, is we said n approached infinity, which means an infinite number of rectangles, of the summation of f of c of I delta x, where sometimes we're using the left-hand side, which is x to the I minus 1, and sometimes we're using the right-hand side, which is x to the I, and of course delta x is still that same function. So this is really just a slide that's summarizing what we've already done. Nothing new on the slide. So if you understood those examples we went through, that's exactly what this is saying. So let's take a look at an example where I find the area by the limit definition. Now let's remind ourselves that we just discovered that if I took the left-hand side limit as n approaches infinity, it was going to equal the limit as n approaches, whoops, not 8, but infinity, of the right-hand bound. And so the one that's less messy and less work is the right-hand side, so that's what I'm going to use. So I'm going to use all of those things I just did, but instead of using the 1 minus I, which is for the left, I'm just using the right-hand side, which is just using I. So let's take a look at all of the parts. Remember, what I'm doing is I'm essentially finding the area from 0 to 1 underneath the curve. Notice it's all positive, so I don't have to worry about making any of it negative. And I am finding first the partition of x. So remember, I'm going to take b minus a and divide it by n. So that's 1 minus 0 divided by n, which is 1 over n. 1 over n is delta x. Delta x is the distance or the width of each rectangle that I create based on the fact that n is going to approach infinity. Then of course we're using the right-hand side because it's easier. The end point is found by taking a plus I times delta x, and so here a was 0, delta x was 1 over n, and I was just I, and so I get that the endpoints are I over n. I'm going to then plug that into my function of x cubed. So I've got x cubed is I divided by n cubed, and then still times the delta x. So here's the function essentially that I plugged it into. And then I'm just doing some math here to say, well, this guy is actually I cubed over n cubed, and this guy is 1 over n, and so what I really have is I cubed over n to the 4th. And so what do I want to do? I want to take this n, because it's really a constant, and move this guy to the outside, 1 over n to the 4th, and I'm really now just taking the summation of I cubed. And I cubed is a function or a formula that I know. So this guy was on that summation formulas page. Again, something you'll just want to refer back to. And I'm taking that times my constant of 1 divided by n to the fourth. I'm using algebra to essentially distribute, well, no, FOIL and then distribute and then multiply it by 1 over n to the fourth and then simplify each term. So again, I didn't show all of those steps in between, but the fact that you're in calculus means you should know algebra. How did I get from here to here? I just used algebra. And now I'm going to take the limit of each thing. So the limit as n approaches infinity of 1/4 is 1/4. The limit as n approaches infinity of this is 0, and of this is 0, and so my answer is 1/4. Here's one for you to try, and it's really the exact same process that we just went through. The only thing that might look a little bit different to you is, remember when we found m sub I, which is of course the value that I'm later going to plug in to my function, that m sub I is a plus I delta x. And that's the same function we used before, except in the examples that we've done so far, a was always 0, and now as you can see, a is going to be 1 and b is going to be 2. So the endpoints are 1 and 2. Everything else is exactly the same, so I want you to press pause. Feel free to reference the other example that we just went over, and then work through this problem completely. When you're all done, press play to check your work. So first thing I do is know that it's continuous and it's positive. And the reason that it's important that it's positive is so that I know I don't have to worry about any negative areas. So I'm really just finding that little snippet from 1 to 2. And now I'm saying, let's find delta x. So delta x, again, is the width of each triangle. I'm sorry, rectangle. Triangles would be way more difficult. So the width of each rectangle is delta x, which is always found by this function. And that gives me 1 over n. And then the right endpoint, again, I'm using this formula to take a plus I delta x, which gives me 1 plus in. So those are my two values I'm going to use. And remember that my function is 4 minus x squared. So I'm finding the limit as n approaches infinity of the summation from 1 to n of 4 minus this value squared times delta x. From there it's just a lot of algebra, so I'm squaring and simplifying, so I end up with this. The limit as n approaches infinity of the summation as I goes from 1 to n of that entire function. And then what I did is I essentially distributed. So I said 3 times 1 over n is 3 over n, which I wrote as 1 over n times the summation of 3. And again, notice that I'm purposely writing these summations in a way that I can use those summation formulas that I came up with before. Then I'm subtracting 2i over n squared. So the 2 over n squared is a constant that I moved out. Let me use a different color there. This guy is a constant that I moved out, and then I was left with just I on the inside. So I is the summation, and then I know a summation formula for that. And then the last guy, I took 1 over n times I squared over n, so it was I squared over n cubed. Notice I took the n cubed, whoops, I don't want red. Notice I took the n cubed to the outside and was left with I squared on the inside. Now, I opted not to show you this formula and this formula. I went ahead and just simplified it. So the purple guy is this guy turned into 3 times n according to the formula. 1 over n times 3 times n gave me 3. Using the formula for I, which is n times n plus 1 over 2, I believe, I was able to do some reduction and end up with just 1 plus 1 over n left over. And then of course I took the formula or function for the summation formula for I squared, multiplied by 1 over n cubed, and came up with this. Then from here, notice I was able to drop all of the summation signs because that's what those formulas did, is give me the formula instead of the summation. And from here I'm just finding the limit as n approaches infinity. So the limit of 3 is 3. The limit of minus 1 is minus 1. The limit of this is 0. The limit of minus 1/3 is minus 1/3. The limit of minus that is essentially 0 and 0. So combining all of these together, I get an answer of 5/3.